So here we go. And let's go over these two examples right here. So what did I say the number in front of the radical tells you? This is a -3 times whatever the result of this is. Okay? So is everything okay and centered in there? Thank you, sir. Okay? So we're going to bring down that -3, okay? And put the times, because we don't want to forget that -3 is going to be part of the answer that we get, and we're going to draw the roof. So again, the question is what times what gives me 27, and one of those numbers has to be a perfect square. So that would be 9 times 3, right? We circle the 9, draw the arrow to symbolize that we're pulling out the square root of 9, which is 3. So whatever we pull out of that radical, you guys, needs to be multiplied to the -3 that was in front of it, because it's a -3 times whatever the result of this is. Well, we pulled out the square root of 9, which is 3, and what do we still have left over under the radical? 3. So now, what does a -3 times 3 give us? -9. So our final simplified answer here is -9 radical 3. Okay? Let's do 2 and 28. So, this 2, okay, is going to be multiplied 2 times whatever the result of this is. Okay, so let's bring the 2 down, okay, draw the roof. Okay, so Josh, what times what gives you 28, and one of them has to be a perfect square? Multiples, yes? Yes, 4 times 7. Always put the perfect square first, then the leftover, right? Circle the 4, draw the arrow to symbolize for yourself that you're pulling out the square root. So the square root of 4 is 2, and what's still left over under the radical 7? Are we done? No. We have to do this here in front. What times what? 2 times 2 is 4. So our final answer, our simplified answer of 2 radical 28 is 4 radical 7. Okay? Now what I want you to do is draw a line under that, and I want you to write variables. Okay? So you guys, we already know, okay, and I want you to write these examples, so this is going to go pretty fast. And then what we'll do is we'll put the numbers and the variables together. Okay? We all know that from my original talk with you, when we were factoring the difference of 2 perfect squares, I told you that the even exponents were perfect squares. So is this a perfect square? Yep, that's an even exponent. Is this a perfect square? No. Is this a perfect square? Yes. Is this a perfect square? No. So what we love about the variables with the perfect squares is our answer is going to be x. Done. Why is that? Because what times what gives me x squared? X times x gives me x squared. Just like we did radical 25, right? The answer is 5. That's it. Whole number, right? Well, even though it's not there, you know there's a 1 there. And when we multiply variables with the same base, we add the exponents. So 1 plus 1 is 2. Do you all see that? Okay? So this is not your answer. Your answer is not x times x. Your answer is x, because you're asking yourself the question, what times what gives me what's inside the radical, okay? X. X times x gives me x squared. Now, you guys, because, okay, the odd exponent, so let's do this one. What times what? Let's just do it quickly. That would be what? X squared. Because 2 plus 2 is 4. X squared times x squared gives me x to the 4th. So the square root of x to the 4th is just good old what? X squared. Okay? We have to handle these odd exponents differently. We have to draw the roof. We have to break it down like we did the other numbers. So everybody go ahead and draw the roof. And we have to put the perfect square first. So what times what in variable form, what times what would give me x to the 3rd? I'm going to tell you. Okay? It's going to be x squared times x. Even though it's not there, you know there's a little 1 there, right, you guys? Because 2 plus 1 is 3. Okay, so we know that x squared times x gives me x to the third power. And what did I put first? The perfect square. Why is this a perfect square? Because it's an even exponent, okay? So, but you're not going to have, the 1 there. You know that the teeny little 1 is there even though it's not there. Okay? So, x squared times x gives me x to the third power. Just like we did with the numbers, we're going to circle that perfect square. Okay? And we're going to, what is the square root of x squared? What times what gives me x squared? X. And what is left over under the roof? X. That's your answer. X, radical x, is the simplified form of radical x to the third power. Okay? So I'm going to do x to the fifth power. Now remember, this is only, I would put the star, and I would remind myself of this, okay, when you have an odd, it's only when you have an odd exponent. The even exponents are perfect squares, okay? So when you have an odd exponent, you have to draw the roof and ask yourself, what times what gives me x to the fifth? And you have to use the highest perfect square first. The highest perfect square goes first.
X to the fourth times x.
Yep, x to the fourth times x. Because 4 plus 1 is 5. Okay? Circle that perfect square. Draw the arrow to symbolize you're going to take out the square root of x to the fourth. Okay? Which is what? X squared. And what is still left over? What are the leftovers? X, and there you go. Okay? So, that is our final answer. Now, you guys, it becomes putting the numbers and the variables together. Okay? Okay, Mr. Green.